Okay, in this video we're gonna take a look at the gradients of different lines and I don't want to just give it away, probably the title already gave it away, but let's just take a look. So let's say we have these two lines, and what do you notice about these two lines? Okay, they're straight lines or linear functions, but something really special stands out. I'm not going to give it away, but let's quickly just draw it. We're going to draw both of these using the y-intercept gradient method. So for the first one, it's in standard form. So I'm going to start at -1, which is there, so I can make my little dot there. And because the gradient is 2/1, or 2, it's 2/1, so that looks at the change over y and the change over x. So if I start here and I'm going to jump up 2, because y is positive that way, so if I jump up 1, 2, and for the 1 I'm going to go right or run by 1, and I get there, then I have those two. I can do it again, jump 2, run 1, and have the same spot, and I can draw this line. Let's just get it nice and straight. Okay, so let's make this is function A, just label it A, and that's pretty much straightforward. The next one I'm going to draw again. This one I'll do in a different color. Let's do it in green. Hopefully the green works nice. Here I start with +1, so +1 is my y-intercept. I'm going to jump up 2 again, so the gradient is actually the same. So if I jump up twice, 1, 2, and I jump 1 forward again, I get there, and I can do 2 more and 1 again, and I jump. And when I draw these two lines, something special about them. Let's just draw them. There we go. So what I see here is that these two lines, okay, I didn't do it perfectly, but they are parallel with one another. So it means they would never touch. So I see when lines, or when straight lines or equations are in the standard form and their gradients are similar or the same, then it means those two lines would never touch. They are parallel with one another. So with this info in mind, they can ask us questions and they can say, hey, what if, can you draw a line that goes through the point, let's say they give us this, y. Let's just think of a question quickly. They'll give you something like, okay, draw a line, or give the equation of the line that is parallel to y is equal to 2x minus 1, and that goes through the point, let's say, -1, no, let's say 2, -1. So in this, they kind of, if I had to write the standard form. Let's write standard form quickly. Y is equal to mx plus c. As I said before, sometimes this is b, but it doesn't really matter. It's just a variable. So this is the equation that they want, but they gave us two pieces of information. One, they told us it's parallel to this line. So what do I know about parallel lines? I know parallel lines, their gradients would be the same, or it would be equal. And in this case, I know the gradient is 2. And they also gave us another point, and this point is an x and a y value. And this is the input and an output value. So in this equation, there are 4 variables, but the one I already know. So I could fill this in because this new equation that I have to write is parallel to this line. I know the gradients would be the same. So I can, because m is going to be 2, or 2/1. mx plus c, and now I have a little bit more information, but then I kind of need to find out what the y-intercept is. And the way I can do it is I can actually use these x and y values and pop them in here. So I can do 2 minus 1, and this is my x and my y value. And the y value would be -1. You can put that in brackets because it's always safe. I know it's alone, but let's just put it in brackets anyway. And the 2 is there, and this is an x, 2 goes in there, and then plus c. So now I have an equation with only one variable, so now this is solvable. So what I mean is we can kind of do all kind of tricks here. So minus 1 is 2 times 2 is 4 plus c. I can subtract 4 on both sides, so I'll have minus 5. Well, let's just do it slower. It would be minus 1 minus 4 is c, and then minus 5 is equal to c, or c is equal to minus 5. So now I know after I've done this, the equation that I can write down is y is equal to 2x minus 5. And we can quickly draw this and we can see if it's actually going to work. So if I drew this function, let's just make the point 2, 1 on here just to say this is where we want to get to. So the point 2, 1, where x is 2, this is going to be here. So x marks the spot. So basically in the question they asked me, they want a line, or the function or the equation of the line that would be parallel to a line like this, but go through this point. So let's quickly draw this and see if we hit. So negative 5 is where I'm going to start here, negative 5. And the gradient is 2, so 2 over 1. So it means I'm going to go up 2 and forward 1. So up 2, 1, 2, forward 1. Can do it again. Don't have to, but I see it works. And that's our line. So it's not necessarily more difficult or anything, it's just a little bit of a trickiness involved, because instead of them giving us 2 points, like in the previous video, they gave us a point or a coordinate, and they gave us a gradient. And then they asked, hey, obviously we could have done this graphically as well. They could have just used that point and then do this. But for now, we're just working with kind of, if they gave us kind of weird stuff. So in the next video, we're going to look at what happens when the gradients are perpendicular to each other.